assume that you haven't done it. I don't know. Feel free to jump in with questions and whatnot. And yeah, we'll make it work. And there's some way to record, but we are not currently doing that. We are recording. As I said, we're recording. Yeah. 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 Okay, cool. Okay, so yeah, how do you code with your friends? Oh, you don't. Right. We're stuck. Okay, so there we go. Okay, so the kind of way that I like to start thinking about kind of doing a collaborative project is first, like, what goes into a project? So it's got different pieces. So first, we want to have some kind of documented description of the project. We want to have some code, probably, maybe some data. Probably in that documentation, we want like instructions for reproducing the core stuff, running the code, using the toolbox, stuff like that. That could be the same thing as the description of the project, but often the description of a project is more like, what's the background? Why are we doing this? What's the core question? Versus this other stuff is like, how do you use it? Maybe we've got like tutorials or demos or stuff, to make some figures or like do some key analysis as an example. If you turn your project into a paper, you might want a folder with like the paper files and figures and whatnot, or posters. So that's what's going to go in your project. Okay. Now, how do you organize this stuff? So one kind of key question to help focus is like, who are you making this thing for? So that might be the starting question. So are you like trying to write a paper for your peers? Are you trying to release a toolbox that's going to be used by like some field? Are you going to, have your project just be for you and your like pop-up lab colleagues? That's going to change kind of what you focus on. Also, there's a kind of tempting bad habit to kind of do when you're starting off a project, which is kind of like do everything fast in the easiest way possible without much thought, and just assume that things will kind of organically organize themselves. That's a great way to end up with a big messy folder of like stuff that you will never be able to use again. So the kind of thing that I like to think about, even if you're not motivated to like share something with the world, you can at least be kind to your future self. I hope, because I hope you care about yourself. So you want to ask, like, is this project going to be easy for me to revisit later? Like, if you want to actually make use of the hard work you put in, how can I make it easy for myself to do that? Or if I might want to like change or update this thing later, how can I make it as easy as possible? You don't want to over optimize up front, but you want it to be kind of possible to use the stuff, right? Possibly you care about, correctness. Like, do you care that the code you write is actually doing what you think it's doing? How could you verify? And then if you do care about sharing, how shareable is your code and how shareable do you want it to be? So all of these factors kind of go into, deciding how you might want to set your project up. Now, if you're working on a project by yourself, you can kind of, it's like the, Wild West. You can kind of do whatever you want. Only you are affected. But when you are working as a team, you've got to, communicate. Communication is key. You want to be interacting minds. Okay, now I've said my obligatory interacting minds thing. Okay, yeah, so if there are pieces of your project, how do you sync up about who does what? Or sorry, how do you sync up about what there is to do? Then you have to sync up about who is going to actually do which step. how will all the pieces fit together? Like if you're doing one thing, someone else is doing another thing, how do you communicate in a way that lets those parts fit together? Who's taking responsibility for the final product? So if it's not clear who's going to verify the whole thing, what is likely to happen is, no one will step up into that role, and then your kind of thing won't work, or the organization will fall apart. It doesn't have to be the kind of leader of your project on a given day doesn't have to be the same from day to day, but it's good to have a point person. Okay, I'm gonna figure out who's doing what and hold in my mind a big picture, and I'll push this project forward during this work session or during this day. And then the next day, it could be the same person that takes on that role or someone else. But you want to have someone who you all acknowledge is going to take point that day. And when you're thinking about this stuff, it's going to really help if you communicate upfront, when you're starting the project. This is kind of the first thing you're going to do. Okay. Is this all obvious? Yeah, no. Okay. So there are some kind of key tools that you're going to want to use to accomplish these goals. You don't have to use the particular tools I'm recommending, but I think they work really well. So I'm going to kind of push this view of how to organize, and do what works for you and your team. Probably the most core tool is Git and GitHub. Who's heard of Git and GitHub? Has anyone not heard of Git and GitHub? No. Okay. Does anyone know what it is? No. We don't know. We've heard of it. We don't know. Does anyone know how to spell Git on the screen? Yeah. Okay. Yeah. No. Yeah. You don't know what it is. It's a place to put your project on the cloud. You can't really see. There's a little cloud icon. What's the cloud? We don't know. It's up in the sky somewhere. Okay. And Git is complicated. There are lots of fancy things it does, but in practice, you are likely to do 6 different things with Git. They all have, well, who's used GitHub or Git? Okay, most. Cool. So for those who haven't, these will just seem wow, what's going on? Okay, so you could clone a repository. What that means is you're downloading the contents onto your computer that you have in front of you. You could fork the repository, which means you take the thing that's on the cloud and you make a new copy of it also on the cloud. You could commit a change. So you make a change, you write some code on your computer, and then you want to make it part of your project. And that change is your local copy. You could push your changes back to the cloud, which means you take your local copy and you sync it up with the copy that's on the cloud. You could pull, which means you take your copy on the cloud and you sync it up with another copy on the cloud. Or you could merge, which means you actually incorporate the changes. So when you make a pull request, it's a request to make changes, but merging is when the changes actually get kind of incorporated. So there's no real way to make sense of these terms other than just memorizing and seeing examples. They become sort of intuitive, but I remember when I was first learning about Git and GitHub, they were just confusing. But you could refer to this slide and kind of remind yourself. Does anyone have a good way of remembering this stuff? No, there's no good way. Okay. Yeah, so we could just walk through an example. So, okay. So when you visit a repository, a project on GitHub, it's like going to a website and you'll get a page that looks something like this, right? So the thing up here, like your address bar, that's like where your repository lives on the internet. And then you'll see a little notation here. This tells you the organization that your project is associated with. When you start a project, you might want to kind of add your project to an existing organization. So you like go on GitHub and create a new project. There'll be a button when you go on like, github.com, and you could like make a new organization or add it to an existing organization. But that's kind of like who the like parent company of your project is. And then you've got your project name, which is what your actual project is called. And if you look at kind of this part of the web page, it's kind of like a folder, just like would be on your computer, but it lives on some other computer in the cloud. So it tells you like what's in your project. And you can click on the files and view their contents and all that. Okay. Now, if you want to download the project to your own computer, the first thing you do is you press this green button where it says code, and then you'll see a little address that's like some web address that ends in .git. And then when you want to copy that and then type in your terminal git clone and then that thing, right? And that downloads the stuff that's on the cloud and puts it on your computer. So now whatever that file contents you saw on the website is going to be on your computer. You can also I haven't told you what a fork is. This is a bit out of order. We'll go with it. Well, I'm just going to skip that for now because we don't know what a fork is. Okay. If you make some changes, you can get the status of all the changes you've made on your computer by typing git status inside the folder that your project lives in. And then if you want to incorporate your changes into your local copy, you type git commit and then -a commits all your changes, and -m lets you put a little message. One of the conventions that I like to use is if you have your own copy of your project, you can kind of do whatever you want with it. So you might be working on some idea, but it's kind of not complete. And then you start working on something and then it's lunchtime. So you move on to something else and you haven't quite finished what you're working on. But if you were to drop your computer on the way to lunch, you don't want to lose all that stuff. So the convention I use is you can, in your commit message, you can put square brackets, WIP, work in progress. And that kind of tags that set of changes as something that's not fully formed, but it's just kind of a backup thing. And then when you go back on your history and look, okay, what are the different changes? You can easily see what's the working stuff and what's broken. And then to actually update the stuff on the cloud, you type git push, and you'll see an uploading stuff message. Okay, so if you are already familiar with GitHub, which sounds like many of you are, then be mindful of others who might not be, and so just help each other. You can also ask the TAs. If you're new to GitHub, all this is just it doesn't make any sense. Just ask for help. And when in doubt, basically whatever action you're doing, you always end up clicking these green buttons, and so just click them, see what happens. Okay. All right. So when you're making a new project, the first thing you have to do, obviously, is think of a project name. What are you going to call this thing? If you need to, you might want to create an organization for your project to live in. So if you want to have multiple projects under some umbrella of a question you're working on or the lab you're in, whatever, that'll be your organization. And then when you visit the GitHub homepage, it'll say create a new repository. And when you, I'll show an example on the next slide, but there are kind of two options for making a new project. One starts from another project as a template. That's called starting from a template. And then the other is just starting from scratch, which is like you start with an empty folder. You can do either. I'll show you examples of each. And then if you're starting your project from a template, it'll usually have be preceded with useful files, like a README file that's kind of like a description of your project, and then maybe some empty tests or stuff like that. It'll set up your basic project organization. If you're starting from scratch, you'll just get an empty folder with nothing in it. Okay. So what that looks like is, if you click the Make a New Repository button, this page pops up, and you can see here, there's repository template. It's like a drop-down menu. And if you select, so by default, it says start from scratch without a template or something like that. If you click this menu, it'll let you select any repository that's public on the internet or that you have access to through your account, and you can use it as a template. In my lab, we have this, and you're free to use it, we have this template called LaTeX or LaTeX base, which kind of sets up our lab's preferred way of organizing files. I'll show you what that looks like. So it sets up your README and your various useful files. And then you have to call your project something. And you have to decide, is it going to be a public project that anyone can see, or a private project that only the people you explicitly add can see? And then you click Create Repository, and that makes the thing kind of exist. You can also choose to start a repository entirely from scratch. And to do that, you select No Template under Repository Template. And then you got to name your project. And then there are kind of some kind of default check boxes and options you can select. One is to add a README, and I would recommend checking that. It'll make a file that says, it's just a blank text file that says what's your project's name, which is based on, whatever you call it here. And then let's say your description, and that'll be your start of documentation. You can edit that. Git ignore is does anyone know what git ignore is? Yeah.
Add certain types of file extensions, basically not.
Yeah, so it's if you have some extra files that are made locally or temporary files, stuff that would be annoying to sync and that other people aren't going to need, you can add them to your git ignore file, which is just a text file with the lists of files that are kind of unneeded and you don't want to sync. And then Git won't ask you about them each time. A nice thing to do if you're starting a project from scratch is to select a git ignore template. So if you're writing a project in Python, you can just select a Python git ignore file, and then it'll add all the temporary files that typically get created with Python projects. Okay. I also like selecting a license to go with your project. It tells users how can they use, what are they allowed to do with your code. I prefer the MIT license. It lets you kind of basically others can use and share your code for free, but with credit. I think they can even use it commercially. They can't hold you liable. So maybe that's a downside. You want to be held liable. That's a problem in science. Yeah. No. Yeah. So pick your favorite license, and then again, press the green button and you'll have a repository. The way I like to organize my projects is using this kind of directory structure. So you've got your root folder. It's your folder, that's your repository. And then I like to have a code folder, which has some helper functions usually in there, and then a notebooks folder with Jupyter notebooks that you can run to reproduce the figures or run each one maybe runs an analysis. or some stats or something, or compiles demographic information for your participants. Then I have another folder, data, where the data for the project gets stored. I usually like to separate like raw data that like comes off the measurement devices, and then process data where you've like made it clean and nice to analyze. And then, oh yeah,
So you're saying you want to put your data inside your GitHub?
yeah. So it depends. If you have kind of small data files, I like just putting them on GitHub. There are file size limits on GitHub. So if you have big files, you got to use a different system, and I'll make some suggestions there. For small files, like usually for behavioral data, it's great to do this. And then for like neuroimaging data, typically those files are too big. So, you can't necessarily do this. And then, since I am an academic and many of you are academics, you might want to, the currency of our profession is papers. So we want to probably turn the project into a paper at some point. So I like to have a paper folder that's going to like contain all my documentation related to a paper that we'll eventually write. So it's got like the main files, like all the text and the figures that'll go in the paper. The figures folder usually has like a source directory, which contains like the different panels of the figures. And then I can like piece them together in Illustrator or Inkscape or something like that. Yeah. And, if there's some piece, like if you want to store your data not on GitHub, you can remove the data folder. So it's not critical that you use this exact structure, but it's a structure that I've found useful across many projects. Okay. So, yeah, like I said, if you are coding by yourself, it doesn't really matter what order you do things, how you organize your code. But when you are working with other people, you've got to have some way of syncing up. So a nice system is to have like the original copy of your project, the first thing you make, be kind of a reference version of your project. Like that's the thing that you'll ultimately share with the world, or kind of treat as the like gold standard within your group. And then you can like fork that repository to have a personal copy of the reference, like primary repository. And you can do whatever you want with your personal fork. And like, I don't know, well, except for Paxton, since you're here, often I find that students in my lab and others that I work with are like reluctant to like make commits or like share stuff. But in my view, you want to like commit your changes as often as possible. Like whenever you do like a meaningful thing, it's like if it takes more than 5 minutes to do the thing, that's work you don't want to lose. Or if you have an idea that you want to like keep track of, even if you want to revert it later, make a commit. And you don't have to worry about breaking code if you have your own personal copy. Like it won't hurt the world to introduce bugs or break stuff, or like jot down an idea that's half formed and you might want to delete it later. It's totally fine. But what frequent commits let you do is it lets you like treat GitHub as like, first of all, like a better version of your memory. So if you like start off an idea and then like you realize it's not going to go the way you thought, you can commit, and then you can revert your changes and then start in a new direction. But now you have a copy of the original path that you can go back to later. Or, if you are working on something and then like, you're going to be interrupted in a minute, you can commit your changes, use the like work in progress tag. And so you remind your future self, okay, this code is broken and not working. You can jot down a little note to say how it's broken, and then it's backed up. So, if your computer's lost or stolen or broken or whatever, or gets rained on, dropped in the river, you still have the thing on the cloud and you haven't lost work. So that style of kind of frequent commits allows you to like get past using a single machine and like having your whole life be dependent on your laptop, like not breaking. And it just lets you kind of live more in the cloud. When you're ready to share something, you can submit a pull request to like merge in your changes from your fork to the reference repository. And it also works great if you have like, the reference repository, let's say you have a group of 3 people. Each person is working on a different task, a different part of the project. They're going to be doing, each person might be making their changes in their own fork. And when you merge in your changes, as long as you're not working on overlapping files, everything will kind of be synced up in the reference repository. If you are changing the same files, you'll get something called a merge conflict, and then you have to like ask the TAs to help with that. Or cry. Okay. So make a fork. You take your the web page for your project, and then you press this fork button. And what that does is it kind of makes a copy of your repository. So in practice, it kind of changes the organization name to just your username. So if you'll see in the upper left, like Context Lab, which is my lab's organization, changes to like Jeremy Manning, which is my username. And then as you start to kind of change things, your fork can become out of sync with the reference. So like here, I tried to do a bunch of crazy stuff. This is a total mess. So I'm like, there are like 37 things that happen on the reference fork that I haven't synced up with. And I've done 253 things on my fork. Remember, I like to commit all the time. But this could be like 10 minutes of work. Yeah. Now it's a mess, but eventually I'll fix it up. It's fine though. I'm not harming anyone by having my own personal copy. Someday I'll fix it up and merge it in, and then these changes will become part of the main thing. Okay. You can also see this like menu item here that says issues. Yeah. Has anyone heard the expression like, oh yeah, they've really got issues? Well, it really resonates with me. Yeah, no. Yeah, so issues are just like people issues. It's like, things that are wrong, but also things you can work on, right? So there you go. You use issues, they're like kind of like to-do items, things you want to like pay attention to. So you can like define project tasks. So you can even start a project by having just an empty folder and just making a bunch of issues, like here are the 10 parts of the project, and then write them down without doing that, just like plain colloquial descriptions. You can attach each issue to a specific person in your group. And so that's a great way of like assigning responsibility and having like, we're all friendly here, and there's like, we're volunteering on these projects. So it's not like anything happens if you don't do your thing, but you can outline like, I'm expecting person A to work on this and person B to work on this. And then when you have that conversation in your pop-up lab hackathon and you like go back to your hotel and you want to like do a little more work, you know who was working on what, and there's like a digital record that you can track and go back to and like remind yourself. It's happened fast. And so like anything you can log or write down or track, it just, avoids communication errors, memory errors, etc. You can also like define project milestones. So sometimes like for a new toolbox or like kind of a new project I start, I'll say like, okay, what's the minimum viable product that like gets me from not having something to something I could like share, even if it's not the full vision, it's, doesn't implement all the possible things I could do, draft one of the paper, like what do I need to get here? So I usually set that as like a project milestone. That'll come with to-do items. But then to go from like the minimum viable shareable thing, or just like something you can talk about at a lab meeting, to the thing you might want to submit to a journal or like advertise or something like that, maybe there's a second set of milestones. Or if you want to go from like version 1 of a toolbox to version 2, which fixes all the bugs and annoying things that your users have reported, that could be another milestone. You can like link issues with project milestones, and it's a nice way to track. It's kind of cool. Like when you close an issue, there's like a progress bar. It really feels like you're doing something. I love progress bars. Yeah. Okay, if you have a particular issue like, oh yeah, there's this bug I'm encountering when I plot this thing, I want to make the lines blue, but they're red for some reason. Why is that? Or like if I run this on like a Linux machine, nothing happens. If I run it on a Mac, it's fine. Like you want to maybe discuss that and talk through with your group, like what's going wrong or what are the bug reports. You might want to ask someone, okay, like I saw you made this issue. Can you clarify what you meant here? Or like item 3 of your checklist doesn't make any sense. Can you like expand on it? The like GitHub issues have like a nice forum for communicating and sending messages back and forth, and you can tag like individual people in specific messages. It's quite nice. Okay, so to make a new issue, you click this issues button. And then what that brings up is this screen that has like a list of all the issues that you or others who use your stuff, like, you know, if your project is public on the internet, any random person can add an issue if they want. So, and then you like have this huge list of stuff. And if you click on one of those issues, then what comes up is like a dialogue that says like, okay, what's the title of the issue? Each issue is numbered. So like this particular project, 259 things. Oof. Yeah. And then maybe there'll be a description of like what, you know, what's this problem about, or what's this suggestion about? Who's working on it, etc. You can paste in screenshots. It's very nice. So like, you know, has anyone heard of like Trello or like Asana? Or I kind of use issues as a bad but more convenient version of these like project management tools. So like the you know, nice thing about things like Trello and like these formal project management systems is like, you know, you might have a specific timeline or deadline associated with each thing, or specific people assigned to specific tasks, but it's often like a lot of work to convert your to-do list to one of these things. And I've just found in teams that I'm on, people are inconsistent about updating Trello, say. If you map things out in issues, it's like a one-stop shop for managing your list of stuff to do. Any questions on that stuff? Whirlwind disorganized tour. Great. I'll assume we're all good. Okay. So another thing that comes up is like if you're writing, say, a Python project, often like one of the awesome things about Python is its community of like you've got a large number of libraries that do all kind of like, you know, basically anything you can imagine, but they're not all built into Python. So there are various strategies for like making sure that the code you write can run on someone else's machine. Like you want to make a list of the things you need to install before running it. Or there are things like virtual environments or containers, etc. Requirements.txt files. And all those things are lovely, but they do require like some amount of setup. So one of the tools that, I mean, I'm biased because my lab is putting this out, but I've used it a bunch of times and find it really useful. We've developed this toolbox called Davos that kind of its main role, Paxton alluded to this in his like student presentation, or mentioned it, but it gives you like access to a new, functionally, it gives you access to a new Python keyword called smuggle. And yeah, so if you've heard of like Davos Seaworth, that's where the name comes from. So he's a smuggler. And smuggle is like a forceful version of import. So import is like the legal thing you do to like get goods from one place to another. Smuggling, it like works even if you're not allowed to, right? So smuggling works like import, but if you try to import something that's not installed, behind the scenes, Davos, just by swapping out import for smuggle, Davos will like create a virtual environment in the background, install the stuff that needs to be installed, and import it for you so that it works with your notebook. So it lets you, yeah.
So if you already set up a virtual environment and you use Smuggle, does it add to that virtual environment? Or does it create like
It creates a new virtual environment. So your notebook it becomes this like isolated thing only for the new stuff you install. So it's kind of like, if you imagine like your runtime environment is what you're running the notebook in, that's got whatever libraries and whatever versions of libraries it has. And if you like smuggle something that's already installed in your runtime environment, Davos just acts like import. But if you have something new, then it gets kind of this like new virtual environment gets created and the new stuff gets appended to your like system path. And you preferentially import those new copies. But because it all happens in a virtual environment, it doesn't mess up like your system. So if you install it's a kind of a safer way of, you can imagine just like having a system command that says like pip install some library in a notebook, and that works on something like Google Collaboratory. But if you run it on your system, it could like mess up your other projects, and you wouldn't necessarily want that. So this is like a safe way of doing that. You get like your single notebook file with all your dependencies and all instructions for installing, and nothing on your system changes. Yeah.
So to clarify, if you have a, say like Conda environment or something, and then you use Smuggle, it won't necessarily impact future Jupyter notebooks you're running there. Like they won't install those packages in that environment.
Well, by default, every notebook gets its own virtual environment. There's a way to configure this so that the environment is shared across notebooks, but you don't have to worry about it, especially for these hackathon projects. You can just not care about the back end. Yeah, so it's like a safe way of dependency management that allows you to only have a notebook as your whole thing. You don't have to deal with containers or virtual environments or requirements.txt files, install scripts. It does all the annoying stuff for you. So in previous years, we've like had a Docker day, and it's been a mess. And in fact, Docker doesn't even, it turns out not to be as future-proof as one would hope. But this is actually a really nice system. I use it in all my lab's new projects. Yeah, so to use this thing, the way you like turn a Jupyter notebook into like a Davos enabled notebook with this keyword is you add these 2 lines to the first cell of your notebook. So this line pip installs Davos, and then the second line imports it. Once you do that, your notebook is like Davos enabled and all this stuff is set up. And then you just replace all your import statements with Smuggle, just literally keyword replace. And all of the variants like from, NumPy, Smuggle, whatever, like kind of any variant that import supports, Smuggle supports.
For clarification, but if your system already has the package after Smuggle, it will use the system.
It'll act just like import, or if you smuggle a built-in library like OS or something, it'll just import the system library. So here's like
I'm sorry,
yeah.
I might have actually preceded you, but I know the example, actually, could you go to the next slide? So
Yeah.
you have like the pip arguments over there to the right. If you don't have those, we'll just assume you want the most outdated for.
Well, what it'll do is it'll say, do you already have some, like say NumPy?
Right.
Do you already have NumPy installed? If you do, it'll import it. If you haven't specified a version. If you don't, it'll install the latest.
Okay.
Yeah. So the way you can like have very precise control over how this works is using these comments that have a specific syntax. So it's like, your comment starts and then pip : and then the package name, and you can like set it to a version number. Like just like when you pip install packages, you could say like, I want NumPy greater than 1.0 or less than whatever, or between these 2 numbers or equal to some version. All the like pip syntax is supported here. And that it kind of makes it very clear, okay, I want this specific version of each library imported. So if you have NumPy 1.22.3 installed in your system on your runtime environment, putting this in will install 1.22.4 into a virtual environment and import that updated version of NumPy. And then your notebook will use that updated version. But all the other projects on your computer, on your system, will use the other version that you have installed. So it won't mess with like other things you're doing. Cool.
Next step.
Yeah.
Is impose styles of model. Next time we use that, I for example. It do this, or have to do this.
Well, it's just like import. So if you want to use NumPy in your notebook from later on, you have to, just like you would have to import it, you could smuggle it. The difference is once you run the notebook a second time, it won't have to reinstall it because it'll just use the existing copy on its virtual environment, as long as it's in the same access. Yes.
It's not quite a virtual environment. It creates it rather than replacing your existing environment, it kind of extends it. So anything you don't have. So next time we install the import statement, you get that version that you had smuggled in.
That's a good point.
You get the version you previously had. That's
Sounds possible, actually. Probably not much. So this is not much.
Well, we can think of it like a virtual environment that is only accessible through this one mechanism, but it's like not at least easily reachable by any standard way you'd import. So you think of it like an isolated thing. So if you smuggle NumPy specific version, that's what's going to get imported, even if you don't have it installed in your runtime environment. So that's the key. It lets you, it's kind of like, has anyone used like a requirements.txt file or a Docker container or like a Conda, like one of those environment YAML files? It's kind of like that, like you specify all your package versions, but in those setups, you have like a separate thing you're installing or setting up that like sets up a new virtual environment or container and then installs all the dependencies and all the pieces. Here, the only thing you're running is the notebook that contains everything you need. And then behind the scenes, Davos like handles all the annoying stuff. But it's done in a safe way, so it's like isolated from the rest of your system. Yes.
Does it take a little bit of time if you're trying to smuggle, like say a package that is big that you haven't done a big install that?
Just like, so the first time you install something, it's just behind the scenes, it's calling pip. So if you have like a huge library, the first time you install it, it'll have to download that and set it up just like it would if you call it pip. The next time you install it, it's local. And so it'll reuse it. So, first, if you're running this locally, you can use it either like on a local notebook or in like, something like Google Cloud. If you run it on collaboratory where you're like resetting your runtime and starting from scratch each time, it can take a while if you're like smuggling something big. In your local machine, once you run the notebook, you've got that like virtual environment, so to speak, attached to the notebook. So you don't have to reinstall it each time. It's like every time you use that notebook, you're, calling the same thing. You don't have to re-download it. It's persistent across sessions. So you can make it persistent across notebooks with a different syntax that's in the documentation for this project and for this library. Okay, so anyways, that's what I would recommend. Of course, you're welcome to use containers or virtual, Conda environments, whatever you prefer. Yes.
Is there a way to send me all the packages that you smuggled that are associated with like a certain notebook? So if you just wanted to check and like, oh, I've got a
Yes. Yep. Yep. All the, yes.
Like a pip freeze equivalent.
Yes, there's lots of, there's a ton of customization options that are very, very exciting. Yeah. Okay. Now, okay, so we've got a way to like manage code and projects. We've got a way to like manage dependencies. So all the parts that your project depend on, how do you actually like write your project? So you can use whatever you want. I would recommend using one of two tools. So probably most of you for most of you, Google Collaboratory is going to be the like optimal solution. So all you need is a web browser. You go to collab.research.google.com, and then you've got like a Jupyter notebook thing that runs on Google's servers. So even if you're running on like an iPad or like a or Chromebook or low resource machine, it doesn't matter because all the computations happen on Google's, dime as opposed to your system. You go to this website and then you can like create a new notebook and interact with it. So once you start your notebook, you can share it with your coding friends there's a share menu in the upper right, you'll see, and you can share it just like a Google Doc with other users based on their email addresses. So you could give access to your whole team, and technically you can collaboratively edit a notebook. In practice, it doesn't work quite as nicely as like other Google Docs or Sheets or Slides. So I would recommend like each person working on a different code cell or markdown cell. Otherwise, like their kind of sync mechanism, goes badly. But it's a way to work on code together. You can also have like one person typing and everyone else sitting around and watching, like kind of like a backseat driver sort of situation. Super not stressful. Okay, once you like have something viable that you want to put on your GitHub fork or in the main repository, you can use, there's in the file menu, there's a save in GitHub option. And so you go to file, save a copy in GitHub, that pulls up this dialog box that lets you select, okay, which repository do I want to save this thing to? And which branch, and what's the path of the file, like relative to the root directory. And then you like have a commit message, and that just like puts your notebook on GitHub. And I would recommend checking the include a link to collaboratory button, because that adds a little link at the top of your notebook where you click it and then it like opens in collaboratory and you're back where you started. So it's quite nice. So you can, if you work entirely in collaboratory, you don't need any like command line stuff with GitHub. You can just use the save in GitHub menu. That's your like push to your fork, and then you can like use the GitHub website pull request to go from your fork to the reference, etc. It's nice. Has everyone used collaboratory before? Has anyone heard of Google? Yeah. You don't know what it does. Okay. The other, like for kind of more complicated projects, I like using VS Code. And there's an awesome plugin called Live Share that is great for collaborative coding and kind of fixes a lot of the sync issues that you have in Colab. And I also like setting up Conda environment, even though I use Davos to do like dependency management, there's like really nice integration with Anaconda environments in VS Code that I just turn on just in case I like mess something up. If I accidentally use a pip command in my notebook out of habit, it doesn't mess with my system. Particularly like if you do like deep net stuff and you have like GPU libraries, it like installing the wrong thing just like messes your whole system up. And so I've just learned to be very, very paranoid about isolating everything, and you don't want the wrong version of NumPy installed because that'll mess with TensorFlow, which will like somehow mess with something else. Anyways. Okay, so to download Visual Studio, you go to the code.visualstudio.com. You can just Google it also, or the slides are in Slack. It's got a really nice debugger. That's my favorite part of VS Code. If you've got a fast machine, which probably most of your laptops are going to be faster than like the free Colab tier systems, it could be faster to run your like analyses, or you might have more disk space or RAM. It's highly extensible. There are all kinds of really awesome plugins that you can add to VS Code. And if you are of the like Anaconda persuasion, you can like manage virtual environments really nicely with plugins. So here's how VS Code looks when you boot it up for the first time, and then you like open a project. It's got like a little side panel with just like a file tree, and then you've got like your code with syntax highlighting, and it's got this cool like outline thing that you can use to rapidly go to different parts of your code. Just like any other integrated development environment, but it's a nice one. It's quick to load and kind of lightweight. If you click this play button up here, there's a drop down that has like a little play with a bug next to it, and that's how you enter debug mode. And then when you run it, it's got like a step through debugger. If you use like the MATLAB debugger, it's very, very similar to that. You can like run line by line or step into a function or interact like, with the different variables and then like continue on, etc. So it's super nice. And usually it just works with like minimal, if any, setup. So very nice. If you've used PyCharm, has anyone used PyCharm? The PyCharm debugger is also quite nice, but it requires some like setup. You might have noticed it's kind of finicky if you use the debugger. VS Code's debugger just like kind of works. So, if you install the like Conda or Python extension, VS Code will become adept at managing different virtual environments. So often for a new project, even though I use Davos to like isolate as an extra precaution, and also to make sure my code runs on other people's systems, even if they are starting from scratch, you kind of want to make sure you like smuggle all the dependencies and install everything. So I'll just start from a fresh Conda environment. You can like press the plus sign, name your environment, save it, and then if you like mouse over any of the environments, there's a thumbs up symbol. And if you press that, it like activates that environment for that project. It's super nice. You can like change your Python version and, do all kinds of nice stuff. And then if you want to collaboratively code with someone, you open your file, and if you install the live share plugin, there's a little button at the bottom that it's hard to see, but it says live share. Can anyone read that? You all can. Well, congratulations. Better eyes than me. You click it, and then this like menu pops up, and it's like gives you like a web. The important thing is it gives you like a web link that you can paste your clipboard and share with people. You could send it on Slack, and that lets anyone interact with the stuff on your computer, like your local copy. Very similar to a Google Doc, but it's like, it's roughly as smooth. They don't even need VS Code installed. If they don't have VS Code installed, there's like this web copy of VS Code that everything runs in. So it's super nice.
They don't have the code locally or like.
Yeah, so it's editing on your computer.
So you're actually
Your
the server.
That's right. That's right. Yeah. Yes. Yeah. Well, not everything. So, I mean, they're different. PyCharm is like a heavier weight solution, so it's got like lots of fancy stuff built in, like it and integrate with Docker really nicely by default, and it's got a fancier debugger. In practice, you can get plugins to deal with Docker containers if that's what you do, and the VS Code debugger is quite nice, so I don't really miss anything from PyCharm. Plus, it's just so much. It's like you press VS Code, you load it up, and it's like it's there on your screen. You don't have to wait for all the stuff to load, and like it just feels like you're moving quickly and like making progress as opposed to PyCharm. I'm just like you press something and it's like, there's a pause. And that means science is not getting done. All right. Yeah, okay, so, yeah, you can share small, okay, that's how you like work on files together, right? Now, how do you share data? So you can post small files on GitHub. Big files, the simplest thing to do, not the cleanest or the most, I don't know, whatever. Dropbox is like not open source, so it's like not, you know, satisfying of open science principles and whatnot, but it is easy, and that is often key. Post your data on Dropbox. It could be a zip file, it could just be individual files, whatever. And then like do the right click, get Dropbox link thing to get the address of your file on Dropbox. And what happens when you paste that link is it'll end with ampersand DL equals 0. And that's the link that if someone were to click that, it would like load in the browser. If you change the 0 to a 1, that's the direct download link. So once you copy the address of your file, change that 0 to a 1, and then you can treat it like a, you know, you're directly getting it from Dropbox. Yes. No, it's fine. It's pretty secure. When you get the link, it often embeds like an API key or like a special key, so that like the default behavior is to give access to that file you're sharing. So when you click in your file menu, get Dropbox link, it makes that file shareable for people who have that address. So if you truly don't want to share it, you've got to figure out some other method. So if you do something like Google Drive with like a password, like that gives you more precise control over permissions, etc. Yes.
In the media, it's like you transfer. So you can make a Dropbox transfer. Which you can then send to someone, which will, it'll be the same thing, right? Whoever has that link can see it, but it'll die in like a week.
There you go. I didn't know about Dropbox transfer, so there you go. Yeah, I mean, there are lots of ways to make your data less accessible. I don't tend to try to optimize for that, but it's, yeah, why not? Yeah, you could also like password protect your files, so like no one can actually use it unless they have the password and change it later, etc. Once you get your Dropbox link, like assuming that you want to share it with your group members and whatnot. I mean, like if you have a private repository and you've got like the link to your data in the repository, anyone with the repository will get your data, but the public won't. So, you know, this code block here, which it's on the slide, so you can copy and paste it, will like download your file from Dropbox and load it in. So this is the code snippet that I just reuse when I like want to fetch my data from Dropbox. Okay. So to kind of summarize and recap, and add some new stuff. There's like a set of core tools that you have at your disposal to think through as you're like working on teams. So we already have Slack. I didn't talk about Slack, but you're, I think, all on Slack. You can use that to communicate. So if you want to start a project, start a new channel, invite your group members to the channel, you can share code and files and links through that. GitHub, we've kind of focused on. That's where you're going to share your like to-do items, documentation, code, data if your files are small. Dropbox you can use for big files. You're going to write your code in Google Collaboratory or VS Code. And you can run your code through those tools. And then sometimes I like using like Google Docs or Google Sheets or Slides, et cetera, to like, you know, manage other collaborative, like, you know, other documents that you want to edit as a group. And those could be part of your GitHub repository or not. As a last kind of, where to go from here message, if you're new to GitHub, Eshin, there you are, has a really nice Git and GitHub tutorial that kind of focuses more on the basics. So if what I was talking about with GitHub was just total gibberish, that's a better place to start. I also have strong opinions about like proper coding style. And if you want to learn about those opinions, you can look at that tutorial. If you are new to programming or data science stuff, I have several open courses on that. You're welcome to check them out. Luke has a great talk. It's also linked to here on kind of the computing stack or the data science stack for Python, with lots of neat links. And then this last link is a link to using Jupyter notebooks if you're not familiar with notebooks. And then if you check out our Mind website, there's links to all the tutorials from prior years, and you can pick and choose what you think you want to know about. And any of them are great. All right.
Anyone, I guess, feeling, you don't even have to raise your hand right now.
Yeah, we're
yeah. But if you're interested and you're feeling super overwhelmed at GitHub and something you kind of want to learn, but a lot of handholding, we could probably organize a kind of a novice getting started with GitHub. And we can go to another room and do it too. So maybe if that seems like you might be that person and you don't want to publicly out yourself, feel free to publicly out yourself and talk to that shit. Maybe during the break or something.
Or you could direct message us on Slack.
Oh yeah.
Or Eshin on Slack. Yeah. I mean, Eshin doesn't count. So talking to him is just anonymous. Yeah. Yeah, right. Yeah, it's just you can take any postdoc and just substitute any other postdoc. It's the same. Yeah. Okay. Any questions? That was a lot. Okay.
So
let's maybe take a break.
Yeah.
Yeah.
How long? I think 15 minutes.
15 minutes. Just nap.